Step back in time to 1859, when the world was a different web of wires, connecting continents and people in a way never seen before this period. In this era, the reins of quick communication belonged to the telegraph, an incredible technological invention that revolutionized human connectivity during a time when news took weeks to travel via horseback or ships. These messages could now be transmitted within a matter of minutes. The telegraph enabled businesses to function across enormous distances, serving as a vital component in the machinery of the nascent Industrial Revolution and the emergence of the capitalist model. On top of business communications, the early beginnings of electronic personal messages were also being sent across this wired network, joining hearts and minds in a manner that was previously unimaginable. For the first time, the world was genuinely connected, with threads weaving a global fabric of human interaction. However, this complex network of communication, this world intertwined by wires, was on the brink of an unprecedented challenge that would see us shaking with fear today. In their peaceful observatory, British astronomers Richard Carrington and Richard Hodgson were about to make a startling discovery. They would make this with their eyes fixed on the sun, observing the celestial body through their telescopes. But our protagonists today were no ordinary observers. They were highly skilled in their craft, with a keen understanding of the solar world. The pair spent their time studying the many cosmic cycles, the rhythmic ebb and flow of activity that our star goes through. One such cycle occurs every 22 years, broken into two 11-year halves. On that fateful day, they observed a large cluster of sunspots, a typical phenomenon during solar maximum, which is the period when the sun is most active during this cycle. And what our pair saw that day was something extraordinary, a sudden explosion of immense energy and a visual manifestation of the sun's magnetic field, releasing charged particles from the sun's surface. They directly observed a solar flare bursting from one of the most prominent spots. But little did they know that this observation was the precursor to a powerful geomagnetic storm, one that would shake their understanding of the physical universe itself. The journey from the sun to Earth usually takes light around 8 minutes, but these charged particles take approximately 17 hours, traveling at a speed of around 5 million miles, or 8 million kilometers per hour. As the coronal mass ejection hit Earth's magnetic field, the effects at first were visually extraordinary. Our planet's defense mechanism, the magnetic field, was immediately overwhelmed by the storm of charged particles. This clash of solar and terrestrial forces resulted in spectacular displays of aurora borealis, even as far south as the Caribbean and Mexico. These mesmerizing light shows are actually the result of collisions between gaseous particles in the Earth's atmosphere released from the sun. And all those color variations, those are due to the different types of gas particles that are colliding. Most of these particles are deflected away, but some become captured in the Earth's magnetic field, accelerating down towards the north and south poles into the atmosphere. The aurora's characteristic wavy patterns and the curtains of light are caused by the lines of force in the Earth's magnetic field. The lowest part of the lights is typically around 80 miles above the Earth's surface. People watched in awe as the night sky was set ablaze with ethereal lights, painting a celestial masterpiece. However, these beautiful displays were accompanied by a more sinister phenomenon. Telegraph systems, the primary means of long-distance communication, were severely affected. Sparks flew from the telegraph machines, setting nearby papers on fire, and in some cases, even shocking operators. Could you imagine the surprise of those users? On top of that, as the storm hit, their machines continued to work even after being disconnected from their power sources, only being powered by the storm itself. While at sea, sailors watched in bewilderment as their compasses spun wildly, rendered useless by the geomagnetic disturbances. Their once trusted tools of navigation had been turned into spinning toys, leaving ships at the mercy of the sea for the time being. In a matter of hours, the world had changed. The Carrington event, as it would later be known, had shown us the raw power of our humble star and the vulnerability of our technologically dependent civilization of the 1800s. The immediate aftermath of the storm was a world in confused disarray. Communication lines, once buzzing with messages, fell eerily silent. Navigation systems were thrown off course, unable to find true north. Ships at sea were adrift, their captains unable to chart a course through the unfamiliar celestial landscape. People were left in a strange dichotomy of awe and fear, as they witnessed the sky ablaze with the most dazzling display of their lives. The night sky was so bright that birds chirped, thinking it was daylight, and people could read newspapers without the aid of artificial light. The world was not prepared for such an event. It was a time when humanity was just beginning to understand the power of electricity and had not yet fully grasped the potential of the invisible forces that governed the universe. Personal accounts from that time tell stories of their shock and awe. A telegraph operator in Boston reported that his machine had sparked and set fire. Newspaper reports from the time paint a picture of a world gripped by fascination. The New York Times, describing the event as a celestial bombardment, wrote about the strange and beautiful phenomena observed in the skies. The world had witnessed the power of the sun, and it was a wake-up call. In the aftermath of the storm, scientists were left with the enigma of the shocking occurrence, a puzzle that begged for understanding. The event posed questions about the nature of solar flares and their potential impact on our planet. It was this curiosity that led to a deeper understanding of solar activities, fundamentally changing our perception of the sun. Before, solar flares were merely a curiosity, a twinkling in the sky observed by astronomers. But the event demonstrated their potential for destruction, showing us that these celestial fireworks were not just a spectacle, but a force to be reckoned with. The event highlighted the fact that our planet does not exist in isolation, but is intrinsically linked to the activities of our solar companion. So, scientists started to decipher the language of the sun. They began to understand the patterns and behaviors of flares and coronal mass ejections, leading to the birth of space weather forecasting. This field emerged from the ashes of the Carrington event as a response to the need for predicting and understanding cosmic activities. As a result, our comprehension of geomagnetic storms significantly evolved. We began to understand how these storms, triggered by solar activities, could disrupt our planet's magnetic field, impacting everything from communication systems to navigation, and it was a wake-up call. It brought to light the depth of our planet's vulnerability to the cosmos, reminding us of our place in the universe. Imagine a world where our satellites, power grids, and all forms of digital communication suddenly fail. This isn't a scene from a dystopian novel, but a reality if a Carrington-like event were to happen today. Our society's reliance on technology has become a double-edged sword. On one hand, it has propelled us into an era of unprecedented advancement and convenience. On the other, it has made us vulnerable to the whims of our volatile companion. You see, a geomagnetic storm of a similar size would wreak absolute havoc on our over-dependent society. Satellites, the silent sentinels in our skies, would be among the first casualties. GPS systems would fail, disrupting everything from navigation to timekeeping. Next, our power grids would be at great risk. A surge of geomagnetic energy would overload the systems, causing widespread blackouts. Imagine major cities plunged into darkness in an instant, hospitals without power, and a sudden halt to our transportation systems. Remember the sparks flying from the telegraph machines, igniting close paper and wood? Think if that were to occur in today's world. The economic and social impact would be staggering, estimated to run into trillions of dollars. Recovery wouldn't be a matter of days or weeks, but potentially years or decades. But it's not all doom and gloom. Our understanding of solar cycles and space weather has vastly improved since the 19th century. We now have satellites constantly monitoring the sun, providing valuable data that can help predict solar flares and coronal mass ejections. Governments and organizations around the world are aware of this potential threat. Efforts are being made to harden our infrastructure and develop contingency plans. While we can't stop a Carrington-like event from happening, we can certainly prepare for its impacts on our lives. This volatile event serves as a powerful reminder of our connection to the cosmos and the importance of vigilance in an ever-changing universe.